Now, what if the masses are not equal? All right, so let's so if I have 3 mass that are not equal, it's complicated. So let's start with 2 mass that is not equal. So hopefully you see this is physics way of thinking, right? So you slowly upgrade your problem, and now you can take care of more and more sophisticated problems, right? So now let's deal with 2 unequal point mass. Okay. So 0. Again, let's do with our favorite numbers, 3 and 5. All right, but this time I will have a mass of 2m over here and a mass of m over here. Where's the center of mass? It's not 4 because it's going to be a little bit heavier over here. Let me use a bigger dot. All right, it's going to be a bit heavier over here than here. All right, so here's the trick. Well, let me just assume this is a problem with 3 equal masses. So this is equivalent to the problem of me having 3 equal masses, m, m, and m, right? Located at 3 and 5. So 2 of them is located at 3, 1 of them is located at 5. All right, so XCM, right? So that's the same as having 1 mass of 2m over here and 1 mass of m over here. All right, so the center of mass is now I know how to do it because I've figured that out, right? So the answer is 3 plus 3 plus 5, right? If I use this formula over each 1 plus 1 plus 1, okay, over 3 essentially. So I have 11 over 3 like this, right? So what's 11 over 3? That's just shy of 12 over 3, right? 12 over 3 is 4. So this is 3.666, right? Something like that, or 3 2/3 essentially. So where is 3 and so just shy of 4 essentially, because it's 12 over 3 is 4. So just under 4, right? So that point's 4, but XCM is 2/3. So 2/3 of here. So this is XCM. Okay. Now let's see can we get an intuition of this? What is the distance between here and here? What's the displacement between this point and the center of mass and this point and the center of mass? Well, this point is, this is 3 2/3, right? 3 2/3. So this part is 2/3 units, right? So this part is 1/3, and this part is 1 unit. From 4 to 5 is 1 unit, and from XCM to 4 is 1/3. So together is 1 1/3, which is 4/3, right? So here is 3/3, 4/3. Can you see the distance between the smaller mass and the larger mass? The ratio between that, well, this is twice as heavy as this. Now the center of mass is shifted so that this is twice as short as this, or I should say this is twice as long as this. Same thing, right? And this gives us an intuition on how to clarify, how to calculate this. So can I, because now if I make this more complicated, like 12m and 5m, like, or 12 kilograms and 5 kilograms, how are you gonna do this? You can treat it as, oh, 12 kilograms, so that's just 12 1 kilogram. So I can redo this and say XCM is and it's 3 plus 3 plus 3. I need to add this 12 times, plus 5 plus 5. Yeah, so let's say if I have 12 kilograms here and let's say 7 kilograms here, right? So I need to add, so this is basically 12 1 kilograms. So I add all of those, and then this is 7 1 kilograms. So I add this 7 times, but now I have a smarter way, right? I should do 12 times 3 plus 7 times 5, like this, okay? For the numerator, right? Don't worry about the denominator just yet. For the numerator, I should do that. So here I should have done, so I could identify a cleverer way is 2 times 3 plus 1 times 5. Divide by something else, right? Now, yeah, so where does the 2 comes from? It's the fact that there's 2m, and there's 5, and there's 1m over here. So but m can be anything, right? So can I factor that in here as well? For example, I should be, if I write 12 kilograms, now the units, there's some problem, right? 12 kilogram, because there will be a kilogram on top. At the bottom, I need to divide by kilogram, in fact. So that's my unit mass, right? So the mass is 1, in some sense, I can write the unit mass is 1 kilogram. So this is 12m and 7m, like this, right? So here I could include the fact that I have an m, not just, let me split it into 2 steps in case you're copying notes. So divide by 3, right? In fact, these 2, I can group it. This is I equals to 1, I equals to 2, right? I equals to 1, if I use the I formula over there. So I could just group these together, and this one as this one associating with this term, this one associating with this term, this one associated with this term. But the fact that I'm grouping this together is, yeah, so I'll group these 2 together for it. So 1 plus 1 is 2, like this. Okay, so I'm grouping these 2 and grouping these 2. This one is just staying there. What if I put 2m times 3 plus 1m times 5 and divide by 2m plus 1m? Okay. Is that the same thing? Yes, it is the same thing, right? Because I can factor out the m, I can factor out the m, and that's fine. And they will cancel out top and bottom. Okay, why is this better than this? It's because now I don't have to worry about what the unit is. If this is 12 kilograms and this is 7 grams, I can just put 12 kilograms, 7 gram, 12 kilogram, and 7 gram, and that will still work. Okay, you can convince yourself this is the same as this. Now I want to generalize into a formula so that I can use every time, and I don't have to sort of think through the logic every time, and I can just blindly use the formula. And where does 2m come from? Well, 2m is the mass of the first object, right? So it's the mass of the first object times the position of the first object plus the mass of the second object times the position of the second object, right? Do you agree this equals to this? Okay, and what's on the bottom? Well, 2 comes from the mass of the first object plus 1 is the mass of the second object, like that. Okay, so I can write this more neatly, right? This is identical to sum of I equals 1 to n of mi xi over sum of mi, like this. Okay, and yeah, so now you see we have reproduced the general formula. So if there's number of masses, and let me summarize that over here. So therefore, if we have discrete point masses for discrete just means it's not continuous. You can actually count them. Discrete point masses, the center of mass, xcm, is sum of mi xi over sum of mi. If we're lazy, that's all we write. But if you're not lazy, if you're slightly less lazy, you'll write I, so you know what is the index that you're summing over. And if you even want to be less lazy, you tell people what index from where to where, like this. Okay. So we'll write that down. So xcm, so more formally, xcm is the center of mass. Xi is the position of point mass I. So the ith point mass, if you want. And Mi is the mass of the ith point mass. Yeah, or point mass I. I don't want to erase this. I'll use a different grammar. And one more index is n. One more variable, I should say. N is the total number of point masses. Okay. So you can quickly check if capital N equals to 1. Does it make sense? So XCM is, so I need to just put M1 X1 over M1. Well, it's just X1. That's the position of the point mass I. So that's trivial. So we'll do a check, right? If N equals to 2 and M1 equals to M2, right? That's my case 2B, I think, or 2A. I forgot. I think it's 2A. Then XCM is M1. Where was it? Right. So 2 mass, right? So it's M1 X1 plus M2 X2 over M1 plus M2, right? But if the M's are the same, so here I will have just M X1 plus X2, because if M1 is the same, right? Here I'll just have 2M, the M's cancel, and I'll have X1 plus X2 divided by 2 as your intuition has came up with, right? It's just the average. Now, if the mass is not the same, then you cannot do this step and cannot do this step, and you just have this step. Okay, so it seems to work out everything. You can double check with all the cases. All right, so yeah, so here is only if M1 equals to M2 equals to M, like that. Okay, but that's more general. If it's not, you'll do that. And so you see that this is the power of formulas. Once you have sort of spot a pattern, you can generalize it in something like this. And yeah, and it will apply to every single case, right? So that's why formulas are powerful. But now you know where that comes from. Now, let's try to interpret that a little bit more.